Hello students, in this video we are going to discuss how to generate FM, I mean FM wave or frequency modulated wave, okay, using a indirect method. We can also call that one as Armstrong's method. So in our class we have discussed how to generate FM wave using a direct method. That is, we have used varactor diode in order to generate FM signal. But we have to use tank circuit, LC based tank circuit. So what happens LC based tank circuit? So there is a frequency stability problem occurs because this inductor and capacitor value changes based on our temperature. So temperature affects our um, fluctuation of our uh, frequency, right? So I need stable frequency of generating, but because of effect of temperature, so it changes its frequency, right? So in order to avoid this, here we are using the crystal oscillator, right? So this crystal oscillator generates low frequency 200 kilohertz, okay. So here we won't get the problem of temperature effect and frequency stability problem. That's why we are using the crystal oscillator. Then we are sending the audio frequency input signal into the audio amplifier. Amplifier means what? It amplifies our input signal with respect to amplitude. Then it's sent to this balanced modulator. So carrier frequency and amplified input signal is sent to the balanced modulator. So we will get here double sideband suppressive carrier output. So double sideband suppressive carrier output, which contains only two signals, upper sideband and lower sideband. There is no carrier. So after that what happens? So we are doing the 90-degree phase shift. So we are doing 90-degree phase shift. So it is after that it is entered to the combined, right, block. So here, so generated carrier frequency signal is stored in the buffer while performing the balanced modulator operation, right. After that, once it is 90-degree phase shift occur, so it is enter into the combined block. So we will get the phase modulated signal, right. So here, as I said, we are generating the frequency modulated signal, but what is the need of generating a phase modulated wave? As I said, it is an indirect method. So we are generating the FM signal from the PM wave. So this is the block diagram of FM generation, right? So still we have not generated the FM wave. So from the PM wave we are going to generate. So for the following specification, right? So here we are going to generate the carrier frequency for the 90 megahertz with the maximum deviation of 75 kilohertz. The frequency shift of your carrier signal or change of frequency of your carrier signal, we call that one as a frequency deviation, right? So here our carrier we are going to generate 90 megahertz and with the frequency deviation of 75 kilohertz. Our input signal is 50 hertz, maximum 50 hertz, minimum 50 hertz, maximum 15 kilohertz, okay. So actually these are the specification of your wideband FM. So we have two type of FM. One is narrowband FM. So another one is wideband FM. Here we are going to generate wideband FM. In order to generate FM, sorry. So in order to generate wideband FM, so we need the phase shift. So the permissible phase shift is 30-degree, right? In order to generate exact FM signal, so without any distortion, right? So because of phase shift, right? So we need to maintain the 30-degree phase shift in our carrier signal in order to generate exact original wideband FM signal. So we are representing this degree 30-degree phase shift with respect to radian. So in order to convert the radian, we have to use pi divided by 190, right? So after that we have to find out. So for the input signal 50 hertz, we have taken minimum modulating signal 50 hertz. So we have to multiply this phase shift 30-degree phase shift with respect to radian with the 50 hertz. So we will get 26.2 hertz, right? So I have to generate 90 megahertz frequency with the frequency deviation of 26.2 hertz. So here, as I said before, so we are using the crystal oscillator in order to generate 200 kilohertz, right? So but my requirement is I need to generate 90 megahertz, okay? And my frequency deviation for the minimum modulating signal 50 hertz is 26.2 hertz, right? So approximately, so in order to make easy, so we have taken 25 hertz, right? But my required specification is plus or minus 75 kilohertz frequency deviation. So what should have to do? So from the low frequency I need very high frequency 90 mega kilo to mega, right? So here hertz to kilohertz frequency deviation. In order to get that, what should we have to do? So we have only one option, is doing frequency multiplication, right? So how many times I have to do frequency multiplication? So in order to find out that, so we have to do division operation. So 75 kilohertz, this is our required frequency deviation. This is your achieved frequency deviation 25 hertz. So if you are doing division, we will get 3000, right? This is our theoretical calculation, but in practically we can't achieve 3000 exactly. So we can achieve 2916, we can achieve 2916. How we are going to achieve? By using the doubler and tripler frequency multiplication. We'll see one by one what is the doubler and tripler. See here, this is your exact original how to generate the FM signal by using the PM. This is the black diagram of frequency modulated using a Armstrong method. Indirect method, we can also call that one as Armstrong method. This is the typical block diagram. So till now we have discussed it, right? So in this we have generating the PM signal, but we are not, till now we have not generated FM signal, right? So what we should have to do? So we have to do phase shift. Then after that, so we have to do doubler and tripler frequency multiply. This is our doubler and tripler, right? How many times we are doing means, so two times. So two times we are doing the doubler and six times we are doing the tripler, okay? So by using this doubler and tripler, two times of doubler and six times of tripler, we can achieve only 2009. Practically we can achieve 2916. We can't achieve 3000 frequency multiplication, right? So see here, so once if we are getting this, so as I said before, there is no difference between the PM and FM wave, right? So it is very difficult to find out which is PM and FM, right? So after we are achieving this PM, we are sending to the amplifier. So the amplified input signal we are sending to the doubler in order to doubling the frequency. So here we have achieved 200 kilohertz carrier frequency and plus or minus 25 hertz frequency deviation, but my achievable, my required frequency deviation is, what is that, plus or minus 75 kilohertz, and carrier frequency is minus 90 megahertz. But it is this our low frequency carrier frequency. In order to achieve that, we have to do doubler and tripler. See, so once if we are sending to the doubler, we achieved 400 kilohertz carrier frequency and plus or minus 50 hertz frequency deviation, right? 200 kilo plus 200 kilo, 400 kilo, plus or minus 25 plus or minus 25, it is a plus or minus 50 hertz. Similarly, we have to send, till now we have not achieved our required carrier frequency. So again I have to send to the tripler. So I got 1.2 megahertz with the plus or minus 150 hertz. Again it is not achieved here. Again I am sending to the amplifier. So that amplified signal we are sending to the tripler, right? So here while doing the tripler itself, I have achieved 3.6 mega plus or minus 450. Again I am sending to this one. I have achieved 10.8 megahertz and plus or minus 1.35 kilohertz frequency. Till now I have not achieved required specification. Again I am sending to the tripler. So after that, why we are not sending to the tripler again? Because once if you are doing, if you are sending without doing this mixer operation, if we are sending directly to the tripler, so we are going to achieve uh, what is the value? So we are going to achieve 583.2 megahertz. We are going to achieve, but my required carrier frequency is 90 megahertz. But obtained theoretical calculation 583.2 megahertz. So in order to reduce my carrier frequency, I have to send, before sending to the tripler, so I am going to send to the mixer, right, with the crystal oscillator 27.4 megahertz in order to reduce my carrier frequency. I am not changing this frequency deviation. I am reducing only my carrier frequency from 30.4 megahertz to 5 megahertz. So what I said, why I am doing this mixer, otherwise I can achieve 583.2 megahertz. If I send to the tripler, doubler and again like this, finally I will achieve 583.2 megahertz. In order to reduce that, I'm sending to the mixer. After that I will send to the amplifier. Then again I will send to the tripler. So I have achieved for 45 megahertz carrier frequency and 36 plus FM signal, and with the frequency deviation 36.45 kilohertz. Again I will send to this one, to the doubler. After sending to the two tripler, I am sending to the tripler. So I have achieved 90 megahertz with the frequency deviation 72 point. My required is 75, but it is, we can't achieve exactly, right, due to many reasons. So we have achieved only 90 megahertz. This is our required FM signal with the frequency 72.9 kilohertz, right? So in this way we are achieving the required FM signal with the frequency division plus or minus 72.9 kilohertz. I hope you are able to understand how we can achieve the FM signal from the PM signal, and we call this one as an indirect method, or we can also call this an Armstrong method. Armstrong is a scientist. He is only conceived this concept. Thank you.